All right. All right, so today we're going to look at some of these carbonyl additions, and then we're also going to look at the retrosynthesis. We're going to start that. That'll probably be in the second half of the discussion, right? But now we want to look at the carbonyl additions. So I'm going to put a date on here. It's 19. So here we have a ketone, and we have a granular, and remember it is a granular plus an aldehyde or a ketone is going to give you an alcohol at the end. If you'll notice too, we have our proton source. So let me go ahead and label that. Right, and that's just the quench, the quench step, the final step to make your alcohol. All right, so here's my granular. This is all I care about. So we're actually gonna add this carbon right here and everything that's attached to it to the carbonyl. So we're going to add it to this carbon right here. Right. And without going through like the entire mechanism, I'm just going to show the arrows for the addition. All right. And then we'll draw the intermediate, and then we'll draw the show the quench step. And we got room for that. So we'll have to cut it out. All right. So I'm going to draw an arrow from here to here, like so. And then of course, when that granular attacks the carbonyl, that CO pi bond is going to have to break, right? All of these carbonyl additions work the same way. Anytime you add a nucleophile to a carbonyl, this is the mechanism. The nucleophile is going to attack the carbonyl carbon, and you're going to break the CO pi bond. Right, break the carbon oxygen pi bond. So you're going to get the intermediate, and I'm going to put it in brackets. So many carbon, 1, 2, 3. So this is what my intermediate is going to look like. I want to draw. So that CH3 is still there. And I got 1, 2, 3, 4 carbons there. I'm going to change the color on that. So that's negative. And then my magnesium salt is going to hang out there. So it's MgI, which is positive. Right, so this is the intermediate. Anytime you add a nucleophile to a carbonyl, you're going to go through an intermediate like this. This is what we call a tetrahedral intermediate. And this is common, right, to all carbonyl additions. Right, all carbonyl additions go through this tetrahedral intermediate. And then in the next step, we want to quench it. So we're just going to add in H plus, right? When you see H3O plus, that's just a generic acid. It can be any acid, right? That's your source of protons, right? So in the next step, this is your quench step. Right, so in the next step, you just add a proton to oxygen, and you'll get your alcohol out. I'm gonna cheat and see if I can copy this. Paste it over here. All right, and that's my final product, which is an alcohol. In this particular case, we get a tertiary alcohol, which is what we always get from addition to a ketone. Right, so anytime we add a nucleophile to a ketone, we're going to get a tertiary alcohol. All right. Questions about what we just did? Anything? And all of it, the reason I went through it like that is because all of these carbonyl additions are the same. You add a Grignard or you can add a Gilman, either way. You add it to the carbonyl, you get the intermediate, and then you quench the intermediate with a proton.
What happens to the salt?
Good question. So the salt, the magnesium iodide salt, which is right here, whatever the conjugate base is of the acid. So let's say we used, instead of just H plus, I'm gonna use HBr, all right, as my acid for the quench. So whatever the conjugate base is of the acid, which in this case would be bromine, it's gonna end up with that salt. So it'll be the alcohol, and I'm gonna just change colors right quick, plus BrMgI, right?
Okay.
Whatever the conjugate base is for your acid, it ends up with magnesium. And again, we talked about this on Wednesday. It just goes in the trash, right? Once you do your workup, you add it to the separatory funnel, add in some type of aqueous layer, ammonium chloride or water or something like that. And then you shake the two layers together, let them separate, keep the organic, trash the aqueous. So that salt is going to end up more than likely in the aqueous layer, and you know it's not of any use to us. All right, good question. Good question. All right, let's look at the next one, which actually let's skip to number. Let's skip to here. This one right here. And then we'll go back and deal with the ester. I'm gonna have to cut that out because I need to explain that in a little bit more detail. Because depending on the stoichiometry, that's going to determine whether you get out of alcohol or whether you get out of ketone. So we'll go back to that one. But let's do this one real quick. So here's my acid for my quench. All right, so that's that second step is, that's acetic acid. Right, it looks like this. All right, this is the part that's labeled OAC. That's just an abbreviation for that. It's an acetate group. Oh, sorry. All right, so that's my acid. We're not worried about that. Here's my ketone. The carbonyl carbon in the ketone is going to receive the nucleophile, which in this case is this Grignard right here. All right. I'm gonna redraw that because the resolution is kind of bad. So it's important to know when you see a Grignard that this is the carbon that's bonded to magnesium, right? That's important because when you add it to an electrophile, you need to know which carbon is going to actually attack the electrophile. So I'm actually going to draw that out so you can see it. So it looks like this. And remember, because it's an organometallic, the bond between magnesium and carbon is covalent. It's not ionic. And it's polarized towards carbon. So that's why carbon is nucleophilic. All right. So where would you start? How would you show your arrows here? Actually, you know what? Let's do this. Let me redraw this where I can put them side by side. Let's drag this over here. Right. So what would the arrows look like showing that nucleophilic attack? And then secondly, what would the intermediate look like?
The arrow will come from the carbon attached to the magnesium bromide to the backside of the double bond with the oxygen.
Okay, so from here, like that.
Yes, and then
Because you always have to break that CO pi bond. Right, so in the intermediate, this is a common mistake, and that's the only reason I'm saying this. In the intermediate, it's this whole thing that's attached, okay? That's going to be attached to that carbonyl carbon. It's not the CH, it's not attacking from the CH3, so you want to attach it there. And it's the CH2 with the CH3 still bonded to it. And the reason I'm saying that is because that's a common error that I see all the time when I teach this section, and when students have to go back and work problems. That's a common error, and it's important not to do that, because when you understand how the Grignard is set up and how the bonds are between that carbon and magnesium, then you know that that carbon that's right here is your your nucleophile. It's this carbon. So anything bonded to that carbon is coming with it. All right. So over here, I'm going to draw the intermediate. All right. This is still intact. I didn't touch it. Right now I have oxygen here, which is negative. I have a CH3 that's still intact. I didn't touch that. And then I added in a C. Well, let me write it out, Lewis. I don't want you to get confused. Right, I added in a CH2, CH3. Yes or no? Can y'all see that?
Yes. Yes.
yes,
All right. And the reason I wrote it out in Lewis form is because everything else is in Lewis form. I could have written it in skeletal form, but I want you to actually be able to see what's going on. All right, where's my magnesium bromide?
the leaving group.
Yeah, but where is it going to be located?
Next to the oxygen.
Yeah, sorry about that. That was my mom calling. If you couldn't already tell from the ringtone. I would have silenced it, but she actually tested positive for COVID. So I wanted to make sure she was all right, but she's doing good. So praise the Lord for that. But anyway, I heard somebody say where magnesium will be, and you're correct. Now we just need to quench it. So we're going to do this. We're going to put HOAC. We're going to just write it like that. All right. And the reason I'm writing it like that is because I want you to see where both things go, because this is important too. All right. So where's the H going?
With the oxygen.
Right. So I'm going to just do that. Just a simple proton transfer. Right. And so my product, let me steal this. Write that in. So that's now OH, which is our desired product. Remember, it's a ketone. So a granular plus aldehyde or a ketone equals the alcohol. All right. So that's that. And then plus, right, we have, what was it, MgBr here. So OAC, MgBr, because remember, this is my conjugate base from the acid. So that ends up wherever magnesium ends up. All right. So that's the outcome of that reaction. You have a ketone, you added a granular to it, and then you end up with an alcohol. All right. Let's do the next one, which is a similar type of problem, right? And notice again, because I started with a ketone, this is a tertiary alcohol as the product. I'm saying that because I'm setting you up for the retrosynthesis part. Because anytime you see a tertiary alcohol, then you can assume that you generated that from a ketone. All right. That's one of the ways to synthesize tertiary alcohols. All right. Let's do the next one. Somebody walk me through that one. Or if you can, let me see if I can let, sure. Yeah. If you have a touch screen, you can actually write on the screen too. So, yeah, let's walk through that. And then we're going to go back up and deal with the esters. And then we're going to come back down here and work through a couple more of these problems. Any takers on that? We got. Okay. I see somebody taking the bull by the horns. All right, with it. Okay.
I think I did that wrong. I'm
I
confused.
think you just added one carbon too many. There's 4 carbons in that chain. Okay, good. Great. All right, great, 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 excellent. Yeah, so she started out with attacking the carbonyl, just like we already showed. It's the same process. You attack the carbonyl carbon, you break the CO pi bond, you get your tetrahedral intermediate, right? And then from that, you protonate that using proton transfer with the acid, quench it, and you get your alcohol. Excellent, nice work. Let me draw the product in the notes, and then you can erase. I'm gonna just change the color of that. Yeah, so that's the product plus this magnesium salt. Very good. Right, and this is, let me put your intermediate back down. This is the intermediate. That, and then this is the nucleophile that was added. All right, that's really good. Nice work. All right, let's go back up. Before we do, are there any questions? No. All right, we're going to go up and deal with the addition to esters, and then we're going to come back down here and do a couple of these problems. And then if time permits, we'll do the retrosynthesis problems where you have to work backwards. That's all. It's a fancy term, but it just simply means to work backwards. And then we'll finish that up. If we finish it between today and Monday, then we'll take the test on Wednesday. If we don't, then we'll take the test on Friday. All right. So let's go back to, and then we got a couple, these are all retrosynthesis problems right here. So we'll work on those too, and these. But let's go to here. And I want to show you with the ester, that the products depend on the stoichiometry. Right, so if you have two equivalents of your nucleophile, you're going to get out, plus a quench step, you'll get out of alcohol. If you have, let me move that up because I know I'm going to get cut off. You have one equivalent of your nucleophile, you're going to get out a ketone. All right, so that's important to know because depending on where am I? Depending on the stoichiometry, then that's going to determine what you have in the product. Right, so let me cut this out so I can show you both. All right, so you have your ester here, right? And so we're going to go through the mechanism. You have a vinyl granular, and keep in mind all this stuff right here that's attached is going to go with that carbon. So it's this carbon in the granular right here that's going to do the attacking. Carve this out a little bit. All right. So if I put the arrows in, and this is important because again, you're going to get a tetrahedral intermediate, but it's going to look a little bit different from what you're used to seeing. right? So the tetrahedral intermediate is going to look like, this. So this is still intact. I didn't touch it. This is still negative. I'm gonna put the magnesium here. And then I added in, let me put the methoxy still here. That doesn't change, right? But what I added in was that vinyl group. So let me show you that. So this is attached to this carbon like that. That's the group. Can y'all see that? This is the group that I added in. The whole group. All right. Now this intermediate, right? It's going to decompose. All right, and I'll show you how. So it's going to actually decompose through an elimination. Right. Because keep in mind, and you might be wondering, like, why can't we just quench it or stop it? But the thing is, the quench step it's not a one pot reaction. Well, it's a one pot reaction, but it's a separate step. So while you're running this, and the way you would typically set this up again is you have your ester or your ketone or your aldehyde in a flask, you seal it up, and then you would add in your granular slowly over time. And then in doing so, the reaction is happening, right? So you don't quench it until afterwards. And so that's why you don't see a quench step or a second step, because all of this is all happening. And then after the reaction, that's when you do your quench or your workup. So what happens is when you get to this stage is you decompose through elimination. And I need to fix those long pairs. So this is coming here like that. And I'm going to kick off the methoxy group. Right, so that's a elimination. I add it, and then my addition product was the intermediate, and then after that, that's going to decompose through elimination. Let me move this over some so I can draw. Right, so this is going to actually give me a ketone. All right, questions about that? Or about what just happened?
Why did it decompose again?
It's just that's the nature of the addition to an ester, right? It's that intermediate is not going to stay like that, right? So the intermediate is going to decompose just because of the nature of the start material, which is an ester. Right, so it's gonna once you form the intermediate is going to seek to stabilize itself, and the best way to do that is to eliminate off a group and reform that carbon oxygen pi bond. Right, it's energetically favorable to make a CO pi bond. Even though you're breaking a CO single bond, you're making a CO double bond. So that's the thermodynamics behind it. But that is with one, if you notice here, we only use one mole. Right? If you add in a second mole of granular, so if I took that I'm gonna just say add one more equivalent. Right, if you add a second equivalent of Grignard, same Grignard, right? I'm just gonna keep that one. Right, so I'm adding in another equivalent of Grignard. That's also gonna attack the ketone. Right, so I'm gonna get from that, I can draw, let me just go ahead and put the arrows in. This is gonna attack like that and like that. So I'm gonna get another tetrahedral intermediate. It's negative. This is MgBr. And let me clarify something too over here, because I know somebody is thinking this but didn't ask it. So when I lose OCH3, right, in that elimination, that's going to form a salt with my magnesium. So over here, I'm also going to have MgBr OCH3. Right, that's a side product from here. Once I eliminate and that OCH3 comes off, because it's going to be negative when it leaves, it's going to just end up with the magnesium. I know somebody was probably thinking that, but didn't want to ask it, and this is positive. All right. So now if I add in another equivalent of Grignard, I'm going to have this, but I'll also have, I'm going to change the color on that one. That, and then plus the one that was already there. All right, are y'all following? Okay. And then all I do from here is quench it. Add in H plus. Whatever acid you want to use is fine. Something weak. And then so when I add in H plus, I'm going to get out this tertiary alcohol. But you see the difference, right? Instead of, if I only add one equivalent of my Grignard, I'm going to stop at the ketone. All right. If I add two equivalents, I'm going to end up at the, and then add in a quench step, I'm going to end up with the alcohol. Right? Questions about that?
Does it only decompose once?
Yes. Yeah,
Okay.
but see this, if it decomposes, you're not going to really gain any stability. You're just going to end up going back and forth in equilibrium between the ketone and the intermediate. So that intermediate, if you add in a proton source to quench it, then you'll get to the alcohol product.
Can you
Good
go up
question.
a little bit?
Go ahead.
No, can you like move the camera up a little bit? Yeah, thank you.
Is that better?
Yes.
Let me move it so you can see the problem too. All right, other questions about the ester
I do have a
addition?
question. So how did we on the first tetrahedral intermediate and
Sure.
like the red, it's like, you know, the one line and then the double bond and then the CH3 on the left.
Hmm.
So on the right one, where did that, like, we only have 3 lines now instead of
Where
4. Like where it says like ketone one equivalent, like in the red where it says the double bond and it says CH3.
Okay, yeah.
But on the left side, we had like that bond and then we had the double bond and the CH3.
It's just it's just a different color.
Oh,
You see
so it's the
how
blue.
I just have it drawn red on the on this side over here, and then it's blue over here, but it's still the same bond to that carbon.
Okay, it's the blue one.
Yeah, let me fix it. How about that? Is that better?
Yes, thank you.
All right. And let me fix this arrow too, because this is definitely not a radical. All right, other questions about the ester addition. So remember with the ester, the product outcome is dependent on the stoichiometry. So if it's 2 equivalents of granular, then you're gonna get an alcohol. If it's 1 equivalent, it's gonna decompose back down to the ketone. All right, any questions? All right, let's go down and do an example. And then we'll just pick up. I don't want to like cram it, so we'll pick up. We'll do. Actually, we can finish these examples here. We'll try to anyway. All right, let's do the first one right here. All right, you see what you're starting with, an ester. And again, I can't stress it enough. The functional group, all the functional group stuff comes directly from part 1. So if you need to go back and refresh yourself on functional groups, do it. Because if you don't understand the functional groups, then the reactions are not going to make any sense. So you got to refresh yourself on that. All right, so notice the stoichiometry. I got 2 moles of a granular, and then I'm following that up with a quench with acetic acid. Without going through the mechanism, what is the product of this reaction? And how do you know? 2 equivalents of granular, I'm adding it to an ester, not a ketone. I can't add it to a ketone because that ratio is always going to be 1 to 1. Same with an aldehyde, that's going to be 1 to 1.
And alcohol.
I'm going to get an alcohol. What is it going to look like? You're absolutely right. What is it going to look like?
Two double bonds.
Let's see. What am I adding to the ester? In other words, look at the composition of the granular, right? Without knowing the mechanism, without knowing the arrow pushing, without knowing anything, I'm adding this group right here. Am I right?
Yes.
And I'm adding how many of them based on the stoichiometry?
2.
2 of them.
2.
Great. So my alcohol is going to look like this. Okay. So this is the OH. I know I'm getting that. And then I'm also adding in this. Notice what I put. It's not the CH3 that's going to bond. It's the CH2 that's bonding to magnesium. That's why I went through it in detail up top. It's always that carbon that's bonded to magnesium that's gonna be your nucleophile, and it's gonna attack. And then I'm also gonna add in another one here. Right? If this was 1 mole, what would I get? If I only started with 1 mole of granular plus that ester,
A ketone.
a ketone, right? And I'm gonna draw it right here. I would get this. Y'all have to excuse these birds. They're fighting over space in a tree in my front yard. Birds fight a lot. I noticed that. Like they are always on edge and angry. All right, questions? Any questions about this? Right. I get a ketone if I use 1 mole, and because I use 2 moles to an ester, I'm going to get an alcohol. All right. So both of those groups are going to add to that ester. All right, let's try this last one and then we'll stop because we got like a minute or so left. What is the outcome of this reaction? And somebody tell me what that is.
A Grignard.
Say that again.
A Grignard.
That's how we make it. Is that what you're saying? That's a Grignard synthesis. That's exactly right. What would the Grignard look like?
Would that magnesium attack the bond between the bromine and the carbon?
Look at that on a Friday, just coming through with all the good information. It's going to actually insert right and end up here. Is that right?
Yes.
On a good Friday. All right, now we got the granular. So this is I'm gonna show you how we would write this without showing both arrows. I'm gonna put all the reagents on 1 arrow, and that's how you can see that reaction depicted that way too. All right, go ahead. What am I going to get from the next step? I have a granular. I'm adding it to an aldehyde.
An alcohol.
An alcohol. Right. So is it going to look like this? Come on, Russell, get your H's together. Yes. Because this is what I'm adding to it. Am I right?
Yes.
And I'm adding it right here to that carbonyl carbon. So that plus trash, right? I don't care about that. This is trash. Going in the waste. All right. So notice with the aldehyde and a granular, I get a secondary alcohol. That's important, because when you're working backwards, if you start out with a secondary alcohol, then that's a giveaway that your starting material was an aldehyde. You start out with a tertiary alcohol, that's a giveaway that your starting material was a ketone or an ester. It could also be an ester as well. All right, so we're going to stop here. We'll pick this up on Monday, and yeah.
Did you say an aldehyde plus a granular gives a 2 prime?
It's a secondary alcohol, yes. All right, any other questions about anything? So the next exam is probably either gonna be Wednesday or Friday. Depends on how much we get accomplished on Monday. And it'll be online, so we'll still have class. Like, I hate not having class to take a test. Yes, go ahead.
Will we having a midterm for this class?
If the next exam falls around the time of midterm, then